Hello, and welcome back to iOS Dev, Vishal. Today, we are presenting a complete in-depth guide to protocol-oriented programming in Swift, also known as POP. Protocol-oriented programming is a core architectural paradigm introduced by Apple at WWDC that sets Swift apart from older languages. In this comprehensive masterclass, we will go through protocols, protocol extensions, default implementations, value types, mutating functions, associated types, and protocol composition, explaining each concept in detail one by one with real-world code examples. First, let's look at the core idea of protocol-oriented programming. Traditional object-oriented languages rely heavily on class inheritance, which can lead to complex subclass chains, tight coupling, and overhead. In contrast, Swift encourages you to start by defining blueprints called protocols. Conforming types like structs and enums can then adopt these protocols, promoting horizontal composition, decoupling, and high modularity. Second, protocol extensions. A common limitation of traditional interfaces is that they cannot hold implementation code. Swift resolves this by allowing you to write extensions for your protocols. Through extensions, you can inject actual computed properties and method implementations directly into any class, struct, or enum that conforms to the protocol, without editing the individual types. Third, default implementations. Protocol extensions allow you to write default behavior for your required methods. This means conforming types automatically inherit working implementations of protocol requirements for free. If a conforming type needs custom behavior, it can simply override the default method with its own custom code, giving you maximum flexibility. Fourth, value types in POP. Traditional object-oriented programming is restricted to classes, which are reference types. POP, however, works seamlessly with value types like structs and enums. In Swift, value types are copied when passed around, which eliminates side effects, guarantees thread safety, and makes your application state predictable and easy to debug. Fifth, mutating functions. Unlike classes, structures and enumerations are value types, which means their properties cannot be modified inside instance methods by default. If a protocol defines a method that intends to change the state of a conforming value type, you must declare the method with the mutating keyword in the protocol blueprint. Sixth, associated types. Sometimes, your protocol blueprints need to work with generic types. An associated type acts as a placeholder for a generic type inside a protocol definition. Conforming classes or structures then resolve this placeholder by specifying a concrete type, such as string or integer, when they adopt the protocol. Seventh, protocol composition. In Swift, it is a best practice to design small, single responsibility protocols instead of bloated ones. Protocol composition allows you to combine multiple protocols on the fly using the ampersand operator. This lets you define functions that require arguments to conform to multiple blueprints simultaneously, keeping code clean and highly reusable. And that is the complete masterclass guide to protocol-oriented programming in Swift. With POP, you can build highly decoupled, modular, and testable code-base applications. If you found this detailed one-by-one breakdown helpful, please show your support by hitting the like button, leaving a comment, and subscribing for daily iOS masterclasses.